All right, today we're going to pull back the curtain on something you use every single day, probably without even thinking about it, the web application. Let's dig into the tech that basically runs our digital lives.
I mean, think about it. Do you use Gmail? Watch Netflix? Do any of your banking online? If you said yes to any of those, then congratulations, you're already an expert user of web applications. They're like the invisible engines of the internet, powering pretty much everything from behind the screen.
So, here's our game plan. First, we'll nail down what a web app even is. Then, we'll look at this client-server dance that makes it all work. After that, we'll meet the building blocks, see how it all comes together, and wrap up with why any of this actually matters.
Okay, section 1. What is a web app? We're talking about the apps that live right inside your browser.
So the formal definition is a software program that runs on a remote server and is accessed using a web browser. The two key phrases there, remote server and web browser. This isn't like an app on your phone that lives on your device. Nope. A web app is actually running on some powerful computer, maybe thousands of miles away, and your browser is just the window you look through to use it.
And that leads us to the biggest difference, the real game changer compared to old school desktop apps. You don't have to install a single thing, right? You don't install Gmail on your computer, you don't install Netflix. You just pop open your browser, type in the address, and boom, it's there. No downloads, no waiting for installations. That's the magic of a web app.
All right, on to the client-server dance. So how exactly do they talk to each other? How does something running on a server halfway across the world show up instantly on your screen? Well, it's all about this constant, perfectly timed back and forth.
This whole dance is built on what we call the client-server model. It's actually pretty simple. Your browser, that's the client, its job is to ask for stuff. It's always the one asking for information. And this all happens in an incredibly fast loop called the request-response cycle. It goes like this. 1, you click something. That's the client making a request. 2, that request zips across the internet to the server. 3, the server figures out what you want and gets it ready. And 4, the server sends a response right back to your browser, which then shows you the new page or information. And all that, it happens in the blink of an eye. It's wild.
Okay, let's go a little deeper. Time to meet the building blocks, the actual components of a web app.
So pretty much every web app is built from the same core team of components. You've got the front end, the back end, a database, and a web server. And they all talk to each other using a set of rules we call protocols. Now, the two big players here are the front end and the back end. The easiest way to think about it is this. The front end is everything you see and touch. It's the buttons, the layout, the colors, the pretty stuff. The back end, that's the brain. It's the hidden logic running on the server that does all the heavy lifting and crunches the data. But wait, where does all your data actually live? Like your profile, your emails, your shopping cart. That's where the database comes in. Think of it as the application's permanent memory. It's a super organized library where all the important stuff is stored safely and can be grabbed the instant it's needed. And the final pieces holding it all together are the web server and protocols. The web server acts like a super efficient air traffic controller, directing all the incoming requests and making sure they go to the right place. And the protocols, like that little HTTPS you see in your address bar, are basically the secure language, the rules of the road that make sure the conversation between your browser and the server is private and safe. Okay, so we've met all the individual players. Now, let's zoom out and see how this all comes together to create the experiences we use every day. And this brings us right back to where we started. Your email, Netflix, online banking, social media, all those e-commerce sites. What do they have in common? Yep, they are all classic web applications. And what's really cool is that even though they all do different things, under the hood, they are all built on that exact same foundation. Every single one has a front end you see and a back end with a database doing all the work on a server somewhere. It's a universal blueprint for the modern web. So this is all fascinating from a tech perspective, for sure, but why does it really matter to you? What's the bigger picture here?
Well, a massive piece of the puzzle is security. I mean, check out this quote. Knowing how data flows and where vulnerabilities can exist allows testers to properly evaluate and secure these systems. That really hits the nail on the head. For anyone in cybersecurity, understanding this architecture is step one. It's the absolute foundation of what's called penetration testing. That's where you ethically try to hack a system to find its weaknesses before the bad guys do.
Think about it. Every time you log into a site or buy something online, you are putting your trust in this exact architecture to keep your information safe.
So I'll leave you with a question to chew on. Now that you know what's really happening behind the screen, just how many of your daily tasks, from work to play, completely rely on these invisible web applications? When you start counting, the answer is probably a lot more than you think.
You know, we type web addresses all the time, but do you ever really stop and look at those first few letters? HTTP, HTTPS. They look almost identical, but that one little S is everything. It's the difference between shouting your secrets in public and sealing them in a secure vault. Today, we're going to decode what that S really means for your safety online.
I'm sure you've seen this, right? You land on a web page and bam, your browser slaps that not secure warning right in your face. It's kind of unsettling, and honestly, it should be. That warning is your browser's way of telling you that your connection is wide open, and it all boils down to one missing letter.
All right, so what is this mystery of the S? Well, it's all about that single crucial letter. The difference between HTTP and HTTPS is the difference between shouting your password across a crowded coffee shop and whispering it in a private, soundproofed room. Let's break that down. So at their core, both HTTP and HTTPS are just rulebooks, or protocols, that let your browser talk to a website server to pull up the page you want to see. They're both trying to do the same basic job, but how they do it, well, that couldn't be more different. One is a public broadcast, and the other is a secret message. Now, to really get why we needed a secure option, we have to look at the original HTTP. The best way to think of it is as the internet's postcard. I mean, it was revolutionary back in the day, but it was designed with a massive and very public flaw. So, HTTP stands for Hypertext Transfer Protocol. It was the absolute bedrock of the early web. You know, the simple, no-frills workhorse that just made connections happen. But here's the catch. Its biggest vulnerability was built right into its design. It communicated completely out in the open. And that's the core of the problem right there. With HTTP, every single piece of information, your username, your password, that private message you're sending, it all travels across the internet as plain, readable text. Anyone who can get between you and the server can read it like a book. This is exactly why we call it a postcard. When you send info over HTTP, anyone who handles that data on its journey, from your Wi-Fi router to the servers along the way, can read the entire message. There is absolutely zero privacy. This lack of privacy leads to three huge dangers. First, eavesdropping. Someone can literally listen in on your connection. Second, data interception. They can just snatch your information right out of thin air. And maybe the most disturbing, content tampering. An attacker could actually change the website you're seeing without you ever knowing it.
Okay, so if HTTP is the totally vulnerable postcard, what's the solution? Well, we needed a secure envelope for our digital mail. And that solution, you guessed it, is HTTPS.
That S stands for exactly what you think: secure. HTTPS takes the same HTTP protocol and wraps it in this powerful security blanket, using something called SSL/TLS encryption. You can think of it like a secret handshake between your browser and the website that creates a private, encrypted tunnel just for your data.
And that is the absolute game changer. Instead of plain text, your data gets scrambled into this complex, unreadable code. It travels across the internet looking like total gibberish, and only your browser and the server you're talking to have the special key to unscramble it.
Which brings us right back to our analogy. If HTTP is a postcard for anyone to read, HTTPS is that sealed, tamper-proof security envelope. Nobody in between can peek inside. The message is for the recipient's eyes only, period.
Now, this secure envelope, it doesn't just give you one benefit. It's actually built on several crucial pillars of protection that all work together to keep you safe online. Let's break those down.
This whole security system is built on four key superpowers. First, data confidentiality. Then, data integrity. After that, authentication. And finally, browser trust. Each one of these directly counters a major threat from that old, insecure HTTP protocol. So let's take a look at each one.
First up, confidentiality. It's pretty straightforward. Thanks to that encryption, the sensitive stuff you send, like your passwords, your credit card numbers, all that personal info, it stays completely private. Any eavesdroppers just see a bunch of scrambled nonsense.
Next is integrity.
HTTPS guarantees that the data you get from a website is exactly what the server sent. It stops attackers from sneakily injecting malicious code or changing the content while it's on its way to you. So what you see is what you get, for real.
Now, authentication. This one is so important. How do you know you're really talking to your bank's website and not some super clever fake one? Well, HTTPS solves this with a digital ID card called an SSL certificate. It verifies the website's identity so you know for sure you're in the right place and not on some imposter site.
And finally, all of this builds trust. Your browser basically acts as your digital bodyguard. It sees a site using HTTPS and it gives you that little reassuring padlock icon. But if it sees plain old HTTP, it throws up that big not secure warning, basically telling you to be careful.
Okay, so we've seen the vulnerable postcard and the secure envelope. Let's put them side by side for the final showdown. When you really boil it all down, the choice is crystal clear. On one side, you have the open, exposed, and totally vulnerable postcard. And on the other, you have the private, sealed, and secure envelope. I mean, there's really no contest here. And this table just makes it undeniable. Let's run through it. Encryption, HTTP has none. You're totally exposed. HTTPS is fully encrypted. Security, HTTP is vulnerable to attackers changing things. HTTPS prevents it. Authentication, with HTTP you have no idea who you're really talking to. With HTTPS their identity is verified. And as for browser trust and data integrity, HTTP fails on both while HTTPS guarantees them. It's a complete clean sweep for HTTPS. So the takeaway here is super simple. In today's world, there is no debate. HTTPS isn't just a nice-to-have feature. It is the absolute, non-negotiable standard for any website that cares about its users' security and trust. If a site is handling any of your data, it needs to be using HTTPS.
So, next time you're browsing, just take a half second and glance up at that address bar. Look for the S, look for the padlock, because now you know it stands for a sealed envelope of security. And knowing that, will you ever look at a web address the same way again? It's something to think about.
Okay, let's dive right in. The entire web is built on websites, right? But here's the thing, not all sites are made the same way. At the most basic level, they really fall into two big camps, static and dynamic. And getting the difference between them is honestly the key to understanding how the web really works.
You've probably felt this, even if you couldn't put your finger on it. You land on one site, and it's like a perfectly printed, glossy brochure. Everything is exactly where it should be, and it's the same every time you visit. Then you go to another, and it's alive. It's constantly changing, reacting to what you do. That feeling isn't an accident. It's completely by design. And that difference, that feeling, it all comes down to two totally different ways of building and serving up a website. You can almost think of it as two separate worlds living on the same web, the world of static sites and the world of dynamic ones. So let's start with that first world, the static website. The absolute best way to wrap your head around this is to stick with that brochure analogy. Imagine a digital brochure, or even a printed book. Once it's made, that's it. The content is set in stone until someone goes back and manually designs and prints a whole new version. So, to put it a bit more formally, a static website is all about fixed content. The most important takeaway is this. Every single person who visits that site gets the exact same pre-built files sent to their browser. It's totally consistent, predictable, and simple. Now, this is where it gets really interesting, because that simple, fixed nature has some huge benefits. Static sites are built with just the basics, HTML, CSS, and some JavaScript. There's no complex code running on the server and no database to connect to. The server's only job is to find the file you asked for and hand it over. This makes them incredibly fast, like lightning fast. And because they're so simple, they're also super secure. There are just way fewer doors and windows for a potential attacker to even try to get through. So when is this the right call? Well, think about any website where the information doesn't need to change all that often. An artist's portfolio? Perfect. A simple brochure site for a local business? Absolutely. A specific landing page for a marketing campaign? You bet. If the goal is to present stable information, clearly and quickly, a static site is often the best tool for the job. Okay, so that's the digital brochure. But what if you need more? What if you need your website to be less like a fixed document and more like a live interactive conversation? Well, for that, we need to step into that second world, the dynamic website.
So unlike its static cousin, a dynamic website doesn't just have a bunch of ready-made pages sitting around. Instead, it actually builds the page on the fly, just for you the second you ask for it. The content can literally change based on who you are, what you've searched for, or even what time of day it is. So how does it pull this off? This is where the heavy-duty tech comes in. Dynamic sites use powerful server-side languages, think PHP or Python, to talk to massive databases. And that connection, that's the magic ingredient. It's what makes all the cool stuff possible. User accounts, personalized recommendations on Amazon, real-time news updates. The content is truly generated live from a pool of data.
And you can probably already guess where these are absolutely essential. Any e-commerce store, any major news website, any blog or forum, these things would be completely impossible to run as static sites. They depend on constant updates, user interaction, and personalized experiences. And that's the hallmark of a dynamic website. Okay, so we've explored both worlds. We've seen the simple, sturdy landmark and the bustling town square. Now let's put them side by side for a direct showdown. This is where it's all gonna click. If you only remember one thing from all of this, make it this. Static equals fixed content. Dynamic equals variable content. That is the fundamental difference, and everything else we've talked about just stems from that one core idea. This table just lays it all out perfectly. Let's walk through it. You see content type fixed for everyone on static versus changing and personalized on dynamic. That dictates the technology. Simple front-end stuff for static, complex back-end code and databases for dynamic. Now look at the trade-offs. Performance, static is a clear winner, it's just handing over a file. Dynamic has to think and build the page, so it's naturally a little slower. That directly impacts security, simpler or safer, so static has fewer risks. And you can see how the use cases at the bottom just perfectly line up with these strengths and weaknesses. So this all leads to the big question, which one is right for you? And it's really not about which one is better in a general sense. It's about picking the right tool for the job you need to get done. You're going to want to lean towards a static site if your main goals are pure speed and rock-solid security. If you need your site to load in the blink of an eye and be as hack-proof as possible, and your content isn't going to change every 5 minutes, this is your answer. On the other hand, you absolutely have to choose a dynamic site if user interaction is a must. If you need logins, comments, forums, if you want to personalize the experience for your visitors, or if you plan on updating your content frequently, like with a blog or an online store, then you need the power and flexibility that only a dynamic site can offer. So at the end of the day, that's the choice. Your website is your digital address, your little piece of real estate on the internet. And the fundamental question you have to ask yourself is this: are you building a quiet, permanent landmark for people to visit and admire? Or are you building a bustling, interactive town square where a community can gather and have a conversation? The answer to that question will tell you everything you need to know.
Okay, so have you ever thought about how a tiny little corner shop can eventually grow into a massive, sprawling supermarket? Well, believe it or not, that exact same idea of smart, scalable growth is what powers the websites and apps we use every single day. So today, let's pull back the curtain and dive into the amazing world of web application architecture.
Right? It's a fantastic question. You know, behind every app that just works, there's this hidden blueprint, this master plan that dictates how all the different pieces connect and talk to each other. And today, we're going to take a look at that plan.
So, first things first, let's get the fundamentals down. What in the world is web architecture anyway?
Well, it's the structured design of all the different parts that make up an application. And honestly, this analogy here is perfect. You'd never try to build a skyscraper without a detailed blueprint, right? It would be chaos. It's the exact same for a web application. The architecture is that master plan that holds everything together.
So let's start with the most basic blueprint out there, the single-tier model. You can think of this as our cozy one-room shop. As you're about to see, absolutely everything happens in the exact same place.
In this model, every single component, the part you see and click on, the rules that make it work, and the place where all the information is stored, it's all bundled together on one single computer. Super simple to get up and running, which is why it was great for some older desktop apps, but yeah, it's definitely not built for growth.
But what happens when that little shop starts getting popular? It needs to expand, right? It needs more room. That's when we evolve the architecture to 2 tiers and start splitting things up. And this is a really fundamental shift. We're not keeping everything in that one crowded room anymore.
Now, we're splitting the work into two distinct layers. You've got the client, which is what you, the user, interact with, and then you have the server, where all the heavy lifting gets done.
So here, the client, let's say your web browser, is talking directly to that server. It's kind of like a shop that now has a front counter for customers and a back room for the manager. It's an improvement, for sure, but there's a catch. That server in the back, it's doing two jobs at once. It's handling all the business logic, the rules of the shop, and it's managing all the inventory data. As you get busier, that manager becomes a serious bottleneck.
And that, my friends, brings us to the industry standard, the digital supermarket of web architecture, the powerful three-tier model. This is pretty much how most modern, large-scale web applications are built today.
The magic number here is 3. The real game changer is taking that one overworked server from the two-tier model and splitting its responsibilities in two. This simple change creates 3 distinct, super efficient layers that can all work independently.
So here's the breakdown. You've got the presentation tier, that's the storefront, what you actually see and interact with in your browser. When you click something, it sends a request to the application tier. This is the brains of the whole operation, handling all the logic. And that layer in turn talks to the data tier, which is like a secure warehouse or a vault in the back, where all the application's information is safely stored.
So why bother with all this separation? Well, because it makes the whole system incredibly powerful. Need to handle more customers? You just add more power to one tier without touching the others. That's scalability. Want to redesign your website? You can change the presentation tier without messing with the database. That's maintainability. It just gives you immense flexibility and lets you reuse components down the road.
And look, this isn't just a popular idea, it's the bedrock for pretty much every robust, modern web system you can think of. As it says right here, this model is considered a best practice for building applications that are meant to last and, more importantly, meant to grow.
Okay, so we've seen the one-room shop, the shop with a back room, and the full-blown supermarket. So how on earth do you choose the right blueprint for your project?
Let's just break it down one last time, kind of like a cheat sheet. If you're building a simple, standalone desktop app, the all-in-one single tier is probably fine. For a basic web app that doesn't need to scale much, a two-tier model can get the job done. But for any modern, scalable web application you can imagine, from e-commerce sites to social media platforms, the three-tier architecture is the undisputed champion. At the end of the day, you can see that architecture is all about matching the complexity of the blueprint to the size of the building. There's really no single best model, only the right model for the job. It always comes down to the specific needs of the application you're trying to create. The three-tier model has been king for a long time, powering the web as we know it. But technology, it never stands still, does it? As we dive deeper into a future of AI, microservices, and serverless computing, the big question is, what new blueprints are out there waiting to power the web of tomorrow? Every single time you browse a website, there's this invisible, super powerful duo working like crazy behind the scenes. Today, we're going to pull back the curtain on two of the most critical players in that duo, the web server and the application server. Let's dive into what they are, and more importantly, why the difference between them is absolutely crucial. Really think about it for a second. How can a news site show the exact same article to millions of people, but at the same time instantly pull up your personal profile, your comment history? How does it handle something that's the same for everyone and something that's unique to you, and do it all so seamlessly? Well, the secret, it lies in a really clever partnership. All right, let's start with the first character in our little story, the web server. A great way to think about it is like the super efficient maitre d' at a really busy restaurant. This is your first point of contact, and it's designed to handle all the simple, common requests with incredible speed. So what's our maitre d' actually doing? Its main job is to serve up what we call static content. Now, this is just anything that doesn't change from person to person. The basic structure of the page itself, the HTML, the design and colors from the CSS files, or all the images. It's basically the fixed menu that everyone who walks in the door gets to see.
The whole game for a web server is speed. It's built to be super lightweight and just blazing fast. It speaks the language of the web, HTTP, which is how websites get sent across the internet, and it is absolutely brilliant at one thing, getting those unchanging files to your browser as fast as humanly possible. You've probably heard of the big names here, like Apache and Nginx.
Okay, but what happens when you ask for something that's not on that standard menu? Let's say you want to log into your account or check your online shopping cart. Well, our maitre d' knows its limits, and for a special request like that, it has to call in the specialist, the master chef working in the kitchen, the application server.
This is where the real thinking, the real magic happens. The application server's job isn't just to hand out files that already exist. Its job is to create brand new content on the fly. It runs complex logic, it talks to databases to pull up your specific information, and it generates a web page that is tailored just for you. It's literally preparing your custom order.
So, you can see the application server is the real powerhouse of this whole operation. It's way more resource intensive, and that's because it's doing all the heavy lifting. It's processing logic, it's querying databases, and it's managing all your user data. It handles all that complex behind-the-scenes work needed to build dynamic content that is totally unique to your request.
So here's the thing. These two servers, they aren't competitors fighting for the same job at all. They are collaborators, a highly efficient team. And the real beauty of modern websites is how they work in perfect harmony to give you that fast, seamless experience you expect. Okay, so let's actually follow the journey of a single click you make. Your request flies across the internet and first hits the web server. It acts like a smart traffic cop and instantly analyzes what you're asking for. Is it just a simple image or a CSS file? If it is, bam, the web server sends it right back to you. Done. But if you're trying to log in, the web server goes, whoa, this requires some thinking, and it passes the request onto the application server. The app server does its magic, builds your personalized page, and then hands it right back to the web server to deliver it to you. Now that we've seen them in action and we get what their individual roles are, let's put them head to head. A final, crystal clear comparison. This is where it all really comes together. If you remember just one thing from all of this, let it be this right here. A web server is fundamentally built for speed. It's made to handle huge volumes of simple requests really fast. An application server, on the other hand, is built for power and for intelligence. It's there to handle complex custom requests. Speed versus power. That's the core difference.
And this table really brings it all home. On one side, you've got the web server. Lightweight, low resource use, just serving up static files like HTML and images. Think Nginx or Apache. Then on the other side, you have the application server, the heavy hitter, executing complex logic and handling dynamic, personalized content. Think Tomcat or JBoss. It's this beautiful, clear division of labor that makes the modern internet so incredibly fast and functional.
And that leaves us with one final thought to chew on. In a world that is demanding more and more personalized content, everything from AI-driven recommendations to your real-time financial dashboards, which of these two roles, the web server or the application server, do you think is facing the biggest evolution? It's a pretty fascinating question about the future of the web, and it's all built on this fundamental partnership.
So, have you ever really stopped to think about the internet? I mean, not as some place you go, but as this massive, invisible web of constant conversations? Yeah, seriously. Every time you click, you search, you stream something, there's a secret dialogue happening in the background that makes it all possible. Today, we're going to pull back that curtain and learn the secret language together. I mean, just think about it. We all do this, dozens, maybe hundreds of times a day without even blinking. You type a web address, you slam that enter key, and boom! Like magic, a website just appears. But what's really going on in that tiny little split second? What's the trick behind the magic?
Well, the secret is, it's actually surprisingly simple. It's not magic at all. It's just a conversation. A really structured, predictable conversation between your computer and the computer where the website lives. And that dialogue, that language, it's called HTTP. And it is, no exaggeration, the fundamental language of the entire web. Okay, so every conversation needs at least two participants, right? In our case, you've got the client. That's your web browser. Chrome, Firefox, Safari, whatever you use. Its job is simple. It asks for stuff. And then on the other side, you've got the server. That's the powerful computer that's holding all the website's files. Its job? To provide that stuff. The best way to think about it is like a restaurant. Your browser is the customer placing an order, and the server, that's the kitchen, ready to cook it up.
All right, so how does our customer, the browser, talk to the kitchen? Well, it places an order, of course, and in the language of the web, we call this an HTTP request. This is the first half of the conversation, and it's all about your browser asking for something very specific. And let's stick with this restaurant analogy, because it just works so perfectly. See, an HTTP request isn't just your browser yelling, "Hey, I'm hungry." No way. It's much more like saying, "I'd like the cheeseburger, medium rare, no pickles, and a side of fries, please." Every single one of those details matters. Your browser is incredibly specific. Okay, so the most crucial part of this digital order is something called the request line. This is the absolute heart of the message. It tells the server two super important things. First, what action you want to take, and second, what thing you want to take that action on. It's basically the main course of your order. So what does one of these actually look like in the wild? Well, here's a classic example. First up, you've got get. That's the action, the verb. It just means, hey, give me this thing, or I want to retrieve something. Simple enough? Then you have /index.html. That's the resource, the specific file you're asking for. In this case, it's the website's homepage. And that last part, HTTP/1.1, that's just the version of the language you're speaking. Kind of like saying you're speaking modern English, not Shakespearean. But the order doesn't stop there. Oh no. Along with that main request, your browser sends a bunch of headers. Think of these like the special instructions on your food order ticket. For example, one header called user agent tells the server which browser you're using. Another one, accept, tells it what kind of file formats you can understand. And then, sometimes, there's a body. This part's optional. It's like a little package of data you're sending to the server. You know, like when you fill out a contact form, that message you type goes in the body. Okay, so our browser has placed its order. Now let's flip the script and look at it from the other side. The server has the request, the kitchen has the ticket, and now it's time to reply. And that reply is called, you guessed it, the HTTP response. And just like the request had that super important first line, the response does too. It's called the status line. This is the server's instant feedback. It's the kitchen shouting, "Order up," or maybe, "Sorry, we're all out of that." And this feedback comes in a really simple form, a number. We call it a status code. And this right here, this is the one you want to see every single time. HTTP/1.1 200 OK. This is the server basically saying, "Got it? I understood you. I have exactly what you want, and it's on its way." It is the universal sign for everything went perfectly on the web. So let's just lock in on that number for a second. 200. If you only remember one single status code from this whole thing, make it this one. 200. It means success. Everything worked. It's the big, shiny green light of the internet. But what about when things go wrong? 'Cause they do. And I guarantee you've seen this one. 404, not found. This is basically the server's polite way of saying, "Hey, I totally understood your order, but I looked everywhere in the kitchen and I just can't find it. The page or file you asked for, it's just not there." All right, so let's assume everything went great and we got that beautiful 200 OK. The server doesn't just send back that status, it also sends back its own set of headers, which are like information about the delivery. For example, content type tells your browser, "Hey, this is a web page," or "This is a picture." And then, most importantly, it sends the body. And this is the main event. This is the good stuff. It's the actual content you wanted. The web page, the image, the data. Your food has officially arrived. Okay, so up until now, we've mostly been talking about the GET method. You know, just asking to retrieve data, but the language of HTTP has a lot more verbs than just gimme. These are called HTTP methods, and they let us do a bunch of different things. Let's break down the 4 most common ones. We've already nailed GET, right? That's just for retrieving data. But then you have POST. This is for sending new data to the server, like when you write a new post on social media. Then there's PUT, which is for updating something that's already there. And finally, delete. Well, that one's pretty self-explanatory. It's a really simple but incredibly powerful set of commands. All right, so this is all great for public information, but what about the private stuff? You know, your email inbox, your bank account, your secret cat photos. How does the server know that it's actually you trying to get in? Well, that brings us to the world of authentication. Here's a good way to think about it. The public part of a website is like the main dance floor. Anyone can go there. But some areas are like the VIP section. You can't just waltz in. You got to be on the list. You got to show your ID to the bouncer at the velvet rope. That whole process of proving who you are, that's what authentication is on the web. So how does this actually work? Well, it's basically a simple 3-step dance. Step 1, you log in once with your username and password. Pretty standard. Step 2, If you get it right, the server gives you a little digital ticket. This ticket is called a cookie. Step 3, now for every single request you make after that, your browser automatically flashes that cookie at the server. It's like your VIP wristband, proving it's still you, so you don't have to keep logging in over and over and over again. And where exactly does your browser show this digital ID? Well, remember those headers, the special instructions part of the request? It goes in a special one called the authorization header. This is where your browser presents its credentials. And in most modern apps, this isn't your password, but a long secret code called a bearer token. Think of it as your high-tech, secure VIP pass for the whole night. Okay, let's pull back and look at the big picture for a second. I know some of this might sound a little technical, but this simple back-and-forth conversation, this request and response cycle, it isn't just some minor detail. It is, and I mean this literally, the fundamental building block of the entire modern internet. So why does any of this matter? Why is it so important? Well, because this little invisible conversation is how everything communicates online. I'm talking all websites, all the apps on your phone, all the APIs connecting them. And if you want to understand web security, you have to understand this first. At its core, this is the engine that powers every single click, every search, and every stream you do online. This really says it all perfectly. The HTTP request-response cycle is the heartbeat of the web. It's this silent, constant, rhythmic pulse just beating away in the background, keeping information flowing all around the planet and connecting every single one of us. Just think about that for a second. This conversation happens billions of times, every single second of every single day, invisibly, almost instantly. So the next time you type something into your browser and hit enter, just for a moment, think about that simple, elegant dialogue that's happening just for you, and maybe ask yourself, what does this invisible, universal language really say about the crazy connected world we've built?
Think about it. Every single day, you type in a password, you scan your face, you press your thumb on a screen. It feels so simple, right? It's almost instant. But what's really going on behind the scenes? Well, today, we're going to unlock the secrets of your digital keys and find out how the internet decides if you're really, well, you.
Right? It just happens. It feels like magic. But that simple little act of logging in is actually powered by a really fascinating history of digital keys and digital locks, each one designed to answer one single fundamental question. Are you who you say you are?
You know, when you boil it all down, every single website and app has to act as a kind of digital gatekeeper. Before it can let you in to see your private messages or your photos or even your shopping cart, it has to be absolutely sure who you are. This is the core problem of identity on the internet.
And the solution to that problem is a process called authentication. The easiest way to think about it is like a bouncer at a club checking your ID at the door. Authentication is just the internet's way of checking your digital ID before it lets you in. This one process, honestly, is the foundation of pretty much all online security. So how did this whole thing even get started? To really get a handle on today's tech, we have to go all the way back to the very first and, the simplest digital key.
And that was called basic authentication. Now, I want you to imagine you're at a party and every time you want to grab a drink, you have to shout your secret password across the room. That's kind of what this is. Your browser basically just bundles up your username and password, encodes them, and sends them along with every single click.
Super simple, right? Yeah, but also super insecure. Without that little padlock icon you see in your browser, the one that means you're on a secure HTTPS connection, anyone listening in could just grab that info and decode it. So it was a start, for sure, but the web clearly needed a much better lock.
And that better lock was session-based authentication. Here's how this one works. It's pretty clever. You log in once with your username and password. The server goes, great, I know you. And it gives your browser a little temporary pass, a unique session ID. And it stores that pass in something called a cookie. It's kind of like getting a wristband at a concert. For the rest of the show, you just have to flash the wristband. You don't have to pull out your ticket every single time. Now, this whole wristband system, it worked perfectly for traditional websites. But then, smartphones happened. Now imagine an app on your phone that needs to pull your profile from one server, your photos from another, and your messages from a third one. All of a sudden, that one wristband system gets really complicated really fast. This new challenge needed a brand new solution.
And this is what brings us right into the modern app revolution. This was all driven by our smartphones and these new web technologies like single-page applications. Those websites that feel as quick and snappy as a desktop app. and APIs, which is just how different programs talk to each other. This whole new world demanded a more flexible, more portable kind of key.
Okay, so this led to a massive shift in thinking, from what we call stateful to stateless systems. Stateful, that's our session wristband. It means the server has to keep a list and remember every single person it's talking to. Stateless, on the other hand, means the server doesn't have to remember you at all. Instead, you bring your own proof of identity with every single request you make.
And that proof is the token. This is the game changer. After you log in, the server hands you this secure, digitally signed token. A really common one is called a JWT, or JSON Web Token. And it's basically like a VIP all-access pass. It's completely self-contained, it proves who you are and what you're allowed to do, and you can show it to any server in the system, and they'll know instantly that you are legit.
Now, this whole token idea is the secret sauce behind something that I guarantee you use all the time. You know that little button that says continue with Google or log in with Facebook? Ever wonder how that works its magic without you ever giving your Google password to that new app? Well, that magic is called OAuth 2.0, and it shows this really key difference between authentication and authorization. See, OAuth doesn't give a new app your password. No way. Instead, you're just telling Google, hey, it's okay to let this other app see my profile picture. You're not handing over the keys to your entire house, you're just giving them a key to one specific room. It's called delegated access.
All right, so let's hit pause for a second and just lay it all out. Session-based authentication is perfect for those classic websites, but it really struggles with modern apps and APIs. Token-based is the go-to for all those modern apps, but you have to guard that token like it's your house key. And OAuth, that's the king for social logins, but it can be a little more complex to set up behind the scenes.
So beyond the stuff we use every day, there are also these specialized keys for very specific jobs. This is mostly for businesses and services that need to talk to each other securely without any humans involved.
So you've got things like API keys, which are pretty much just a secret handshake that lets two computer programs identify each other. And then you've got the heavy-duty stuff like SAML, which is a protocol that powers single sign-on, or SSO, in big companies. That's what lets an employee log in just one time to get access to dozens of different work tools. So we've got all these different kinds of keys to get in the door. But how do we make that door stronger? I mean, how do we build a real fortress around our digital identity? Well, the answer is to add more layers of security.
And that brings us to multi-factor authentication, or MFA. And let me tell you, this is probably the single most important security upgrade you can make to your online life. The idea is incredibly simple. Don't just rely on one key. Make a bad guy have to pick multiple locks to get in.
Now, the power of MFA comes from combining different types of proof. Good security always uses at least two of these three categories. First, something you know, like your password. Second, something you have, like your phone to get a text message code. And third, something you are, like your fingerprint or your face. And that third factor, the something you are, is becoming so incredibly common, right? Biometric authentication, using your unique physical traits like a fingerprint scan or your face. It's just so powerful because it's extremely hard for someone to steal or copy. It is literally a key that is part of you.
So let's put this whole journey together. It's been pretty amazing when you think about it. We started with just simple passwords back in the 90s. Then we moved to those session wristbands for the early social web. Then we developed the portable VIP pass tokens for the mobile and API revolution, and now, today, we're literally using ourselves as the key through biometrics.
And, you know, that brings us right to the future. With artificial intelligence making it easier than ever to fake voices and even faces, how are we going to prove who we are online? What is that next generation of digital keys even going to look like? Honestly, that is the huge challenge for the next decade of the web.